Hello friends, welcome to another video of Zeta Axis, and today we are going to discuss about different types of precipitation. We will mainly focus on the process of rainfall, and in brief we will discuss about fog, dew as well as frost, because we have discussed these in another video. In the upcoming video we will discuss about snowfall, sleet, freezing rain as well as hailstorms. The process of rainfall seems very simple, but it is complicated, and we will try to discuss this process in detail. So to begin with, the process of evaporation starts with evaporation of water from the surface of our earth. The evaporated water rises up. This rising water, it condenses. It forms clouds. And after this, the clouds, they will give it back to the earth's surface in the form of precipitation. It could be in the form of rainfall, fog, snow, hailstorms, anything. Now this process can be further divided into different parts. So the first is evaporation, cooling of the moisture. Then there is saturation of air. So the amount of moisture in the air rises to a point that the air becomes saturated. We will discuss this in detail in upcoming slides. Then it gets condensation, that is the moisture which is in the gaseous form. It will convert into liquid form and it will form clouds. After this, there is growth in the size of these water droplets. So this is called droplet growth, and then it falls down, giving precipitation. So let's try to see the important parts of this process. So the first step in the process of rainfall is evaporation. We know that the water is evaporated from the water bodies on the earth's surface. But the precipitation which animals give out, they also give out moisture to the atmosphere, as well as the process of photosynthesis which is conducted by the plants. They also contribute to the amount of moisture in the atmosphere. So we can see that these are the three major sources of moisture in the atmosphere. Because of this process, we will see that the amount of moisture, it increases in the atmosphere. Now this distribution of moisture is not even throughout the atmosphere. We will see that the maximum amount of moisture is concentrated in the lower region of our atmosphere, that is closer to the ground. And as the height increases, we can see that the concentration of moisture in the atmosphere, it will decrease. Now the next step in the process of rainfall is cooling of the moisture. And this can occur by mainly two mechanisms. That is, first, where there is uplifting of the air. So the air which is having this moisture, if it gets uplifted, there are several mechanisms by which this air can be uplifted in the atmosphere. That is, the air moves vertically up. And the second way that the air or the moisture can be cooled down is by cooling of the ambient air. So let's see all of these one by one. The first type of cooling by air upliftment is cyclonic uplift. Here there is a low pressure region in the center and there is high pressure region in the surrounding. So air from the surrounding region is moving towards this region. Here basically a cyclone like structure is formed. The air which is moving towards this low pressure area, it will converge there and it will start to rise up. Now as the air rises up, the temperature of the air will decrease, which is indicated by the color. Here the yellow color shows that the air is warmer and the blue color indicates that the air is cooler. So the moisture which is present in this air, it will also experience the same process. The moisture will also cool down. So this is our first process of cooling of air by cyclonic uplift. Let's see the second one. The second is frontal uplift. Here we know that there is this cold air mass and warm air mass, and this is the cold front where the cold air mass is moving forward, and here we have a warm front where the warm air is moving towards the cold air mass. At both these margins, we will see that the air is rapidly uplifted here and the air is also slowly uplifted here, but the moisture is also uplifted. So here we can see that cyclonic clouds are formed, and here we see that different types of clouds are formed which give rainfall. So in both these processes, we can see that the air is uplifted, and with the air the moisture is also uplifted, which is cooled down to form clouds. The next type of cooling of moisture by upliftment is convectional uplift. Here the solar radiation, it heats our land, our earth. So it does not heat the atmosphere directly, but it heats our earth's surface first. And this is what is indicated by this. This is the earth's surface. and we are heating it by this fire. Consider that the solar radiation is heating the Earth's surface. Now, the air which is closer to our Earth, it will start to rise up, it will cool down, and then it will come back down. Again, it will be heated, it will again rise. So this kind of cell is called convectional cell, and this kind of upliftment is called convectional upliftment. So the similar mechanism occurs in our atmosphere, where the radiation from the sun heats our land. The air which is closer to the land also gets heated, and therefore it rises up. It rises up, it cools down, it comes back, and this cycle continues. So this is also a type of air upliftment which cools the moisture. The next is physical or orographic upliftment. Here, air is moving and it encounters a physical structure like a mountain. So the air will rise up. When it rises up, its temperature decreases due to adiabatic cooling. The next type of cooling of moisture occurs by cooling of ambient air, that is the surrounding air. So here you can see that the region which is closer to the land is having higher temperature, and as we go up in the atmosphere, the temperature decreases. Now during the night or due to some climatic condition, we can see that the region closer to the earth also gets cold. This cool climate or this cool condition will reach to the surface of the earth. So the moisture which is lying over here will also get cooled. So even though there is no upliftment of the air directly, we can see that there is cooling of the air. And because of this, we can see that moisture can condense close to the surface of earth, which generally leads to formation of fog. Now let's discuss the process of condensation. So what is condensation? Condensation is basically change from gaseous state to liquid state. So this process is called condensation. Now for the moisture to condensate, it requires mainly two things. The first is that the relative humidity should reach 100%. That is, the air must get saturated. Now there are two basic conditions for water condensation. The first is that the air should saturate. That is, the relative humidity should reach 100%. And the second is hygroscopic condensation nuclei should be present. Let's discuss both of these in detail. So the first condition is that the air should be saturated. So what does this mean? It basically means that the air should reach the maximum moisture carrying capacity. Now this moisture carrying capacity of the air depends on the temperature of the air. So here we can see that this line, this dark black line which you are seeing, this indicates the maximum moisture carrying capacity or the line of saturation for air at different temperatures. Here is the temperature. So we can see that as we are closer to 0 degrees Celsius, there is very less moisture needed for saturation. So even if there is small amount of like 5 gram per kg, it will condense, that is it will form water droplets. But as the temperature increases, we can see that we require more amount of moisture to cause condensation. Now to further understand it, let's suppose our air is at this point, that is the temperature is around 25 degrees Celsius and it is having 15 gram per kg. Now for this air to get fully saturated or the moisture in this air to condensate, there are two things which can occur. The first is the amount of moisture could be increased or the temperature could be decreased. So either we can increase the amount of moisture and reach over here to cause the condensation of moisture in the air, or we can decrease the temperature of the air. So these are the two mechanisms which should occur if our air is over here. So basically for the condensation of moisture to occur, it should be on this line. Here we can see both the mechanisms by which the condensation can occur. It is either increase in the amount of vapor or decrease in the temperature of air. Both of these things could lead to condensation of the moisture in the air. Now the second thing was that there should be a hygroscopic condensation nuclei. Now this is basically a very small nuclei, very small particle. It could be a dust particle, it could be an aerosol, so which is present in the atmosphere. And it is this hygroscopic nuclei on which the moisture condensates. So without this, it is very difficult for the moisture to change its form, to change from gaseous to liquid state. It will require this particle on which it gets deposited to form water droplets. If we see the procedure, consider that these are our moisture in the air and we have some of the nuclei like this. So over the time, what will happen that these will interact with the moisture in the atmosphere and that moisture will get deposited on the condensation nuclei. So you can see that earlier it was brown, which was the condensation nuclei, and now it is blue because water has been deposited on all sides on it. So this is how our first droplet is formed in the atmosphere. We can compare the size. This is our average hygroscopic nuclei and this is our average cloud droplet. We can see that there is 100 times of difference between the size of these two things. Now because these cloud droplets are so small, they remain suspended in the air because the surface area gives them higher buoyancy than the gravitational pull because of their volume. And that is why we see that these clouds, which are formed of so many small cloud droplets, they remain suspended in the atmosphere. However, with time, these cloud droplets, they will interact with each other and then they will interact and they will become larger. We can see that these smaller droplets, they are now changing into larger droplets. And as this process continues, we will see that the water droplets in the clouds, they become large. And when it becomes sufficiently large, they will start to fall. So here we can see that the cloud droplets increases in size by collision and coalescence, where the water droplets will collide, they will combine and become one, and thus the size of the water droplets will continue to increase. And there will come a point when they will become heavier to remain suspended in the atmosphere. And at this point, we will see that these droplets will start to come back to our earth. That is, there will be precipitation. It could be in the form of rainfall or any other process. Now here is a comparison of our hygroscopic nuclei, the average cloud droplet as well as average rain droplet. So we can see that this is at least 100 to 1000 times larger than an average cloud droplet. And that is why this is heavier and that is why it falls back to the earth. Now we have discussed that there is a hygroscopic nuclei which is needed for condensation of the moisture. But what happens when there is no hygroscopic nuclei? So here, if we see that there is vapor in the atmosphere and the dew point, that is the point when the air will get saturated, it forms clouds in the atmosphere. This is generally above 0 degrees Celsius. So the dew point is generally above 0 degrees Celsius. So we can see that here the moisture in the atmosphere will form clouds. If the temperature of the atmosphere is below 0 degrees Celsius, as we can see by this line, then they will convert into ice crystals which give snowfall. But what happens when there is no hygroscopic nuclei? Then they do not condensate here. They do not form any clouds over here. When the temperature is lower, then they will become supercooled vapor in the gaseous form. And they will form clouds which are seen in altocumulus clouds or which are seen in higher atmosphere. And these types of clouds, they do not give rainfall. If this temperature further decreases and reaches minus 40 degrees Celsius, only then this vapor can form ice crystals. Here the ice crystals are formed without a hygroscopic nuclei. So this is the difference in the process when there is hygroscopic nuclei and there is no hygroscopic nuclei. This type of rainfall is the most common rainfall, while these kind of rainfalls are very rare. Here we can summarize what we just discussed. That is, in absence of hygroscopic particles, the vapor is below 0 degrees Celsius. So the vapor will be in supercooled state till minus 50 degrees Celsius, where it will form clouds. These clouds have vapor in the supercooled state and they do not give rainfall. Autocumulus clouds which are in mid-latitude height are example of this. Now water will remain in this supercooled state unless one of the two things will occur. Either the temperature will fall below minus 40 degrees Celsius or the water vapor encounters a hygroscopic particle. If it encounters a hygroscopic particle, it will form ice crystals and we will have snowfall. However, if the vapor goes below minus 40 degrees Celsius, then it will form ice crystals without hygroscopic nuclei. So it is around this margin of temperature that the water vapor will form ice crystals without requirement of hygroscopic particles. These ice crystals will then attract water vapor from the surroundings and the size of these ice crystals will grow, and then we can have snowfall or rainfall if the ice crystals melt while falling towards the land. So this is what happens when the vapor is below minus 40 degrees Celsius in absence of hygroscopic particles. Now let's see fog. So the conditions which are necessary for radiation fog we have already discussed in detail in our video on fog. So here we can just see that air should saturate with moisture. That is, the air should be present in sufficient amount that it could get saturated when the temperature drops. There should be a presence of hygroscopic condensation nuclei. Remember, the water, it requires a hygroscopic nuclei for condensation. There should be long winter nights. Long winter nights help in causing fog because there will be more amount of radiation or heat that is released from the air. It will reduce the temperature of the lower atmosphere and therefore it will help in the condensation of moisture in the air. Cloudless sky also helps because if there are clouds present in the atmosphere, then they trap the heat which is released by the earth. Thus, they do not allow the temperature to fall drastically. If there is no cloud, the heat that is released by the earth, it directly reaches the space and therefore the temperature can much rapidly decrease and thus help in the condensation of moisture. Slow movement of air is also a necessary condition because if the air is moving too fast, then it becomes difficult for the moisture to condensate. We have already seen that these are the processes by which the air can be cooled down for condensation of the moisture in the air. But for fog, this is the most important condition. Here, the temperature, it becomes lower in the lower atmosphere and thus it causes condensation of the moisture which is close to our land. Now we have heard about fog and mist. So both are basically the same thing. Both are condensation of moisture near the surface of the earth. The only difference is in the density. The fog is more denser and it has a visibility less than 1 kilometer, while mist is less denser and it has a higher visibility, higher than 1 kilometer. That is, you can see for a distance greater than 1 kilometer when there is mist. Let's also discuss dew and frost. The conditions for formation of dew and frost are pretty similar to the conditions for fog. Here, because the temperature of the surrounding air decreases, the grass, the objects which are present there, their temperature also decreases. So the moisture, it quickly deposits on these surfaces where the temperature is lower. Now if the temperature goes below 0 degrees Celsius, then the moisture in the atmosphere, they will form ice crystals on that surface, and that is what is called frost. So if it is in liquid form, we call it dew, and if it is in this ice form or ice crystals form, then we call it frost. And here are the examples of this. Here we can see that these are the dewdrops. Here the temperature was above 0 degrees Celsius, while this is the frost. Here we can see that the temperature of the atmosphere was below 0 degrees Celsius, causing the ice crystals formation. I hope you liked our video on the process of rainfall as well as other means of precipitation. We will further discuss about snow, sleet and freezing rainfall as well as hailstorms in the upcoming video, so do watch them. If you have liked our video, then do subscribe to the channel and share with your friends. If you want to help us, you can use our Paytm link. Thanks for watching the video.